Let's look at 27. If you remember working on it, I'll choose another. I do not remember working on 27, but maybe we did. So y equals x, the square root of 2 plus x, and that is 27 on page 352. Okay. So we're asked to show everything. What do I have to start with? Always.
Domain.
Thank you. So what do I have to write to find the domain? I have to write that. Which one? 2 plus x. So then x must be greater or equal to -2. So obviously the domain is -2 to infinity and nothing else. Very good. So now I have to find everything I can about the function from the function itself, bless you, first. Okay. So obviously I'm going to ask myself, what is f of 0? Because I have to. I have no choice. 0 times the square root of 2. How much? Very good. I do have to plug in -2. When I plug in -2, this will be 0 times -2. And I get?
0.
Very good. So f of 0 was 0. And now also I have to ask myself, when I said y equal to 0, what can happen? And two options, right? When the first factor is 0 or when the second factor is 0. And I did get them. So there is nothing else. However, I also need the limit here. And I'm done with a function. So the limit of x, the square root of 2 plus x, as x approaches infinity. Of course. It's infinity times infinity, which there is no discussion there. What will be my next step? F prime indeed. So let's find f prime. This is a product. I have to use the product rule. The first function prime plus times the second one plus the first times this one prime, which is 1/2 the square root of 2 plus x, times the inner function prime, which will be?
1.
Very good, awesome. I have to find the LCD. And there is only one. 2 to the square root of 2 plus x. Good. So I need to multiply this by 2 to the square root of 2 plus x. Because it doesn't have any denominator, or it has denominator 1. So then when I multiply 2 by the square root of 2 plus x times the square root of 2 plus x, what do I get? 2 times 2 plus x indeed, and plus x. Awesome. I have to distribute, and I get 4 plus 2x plus x over 2 the square root of 2 plus x. And then I have 3x plus 4, final simplified form of f prime, 3x plus 4 over 2 the square root of 2 plus x. What do I need to determine next? After I'm critical numbers, awesome. Critical numbers come from two sources. When f prime is undefined and the function is, and when f prime is 0. It happens that this function has two critical numbers, one coming from each source. So what will be the critical number coming from f prime being undefined? Very good. And what will be the critical number coming from f prime being 0? I have to move 4 to the other side and divide by 3. -4/3. Now let's see if these two numbers are in the domain. Yes. Yes, I am. Thank you. Okay, so at -2, undefined, and so is the second derivative. And at negative 4/3, is negative 4/3 in the domain? Yes, it is. I need the sign of this expression. But I will never bother with this about the sign. Why? Good. So this is a linear function with a positive slope. Before it crosses the x-axis has what sign? And after it crosses the x-axis has what sign? I have to plug this number in, the function. Now I will use a calculator to plug in negative 4/3. So negative, I will recommend put parentheses. Let me do this here better. So parentheses, negative 4 divided by 3. And then the square root. And no matter what it says, I will put parentheses. So this is 2 minus 4 divided by 3. It works this time without parentheses. And I press enter. And I got negative 1.1. And I put it in. Okay, moment of truth. I want to make sure that these two work together well. From 0 to negative 1.1, the function appears to be, is that supported by the sign of the first derivative?
Yes.
From negative 1.1 to 0, is it supported by, okay. And from 0 to infinity, is it supported by?
Yes.
Okay. Now I will look at the second derivative, which is this differentiated. So I will have f prime of x as 1/2 times 3x plus 4 over the square root of 2 plus x. I don't want to bother with that. It's a constant. You can wait for me outside patiently. I don't want to involve that if it's not necessary. The top function prime is 3 times the denominator minus the top times the denominator prime over the denominator squared. It's an ugly function as for the second derivative. It really is. So moving forward, always remember, try to simplify, try to factor, always keep that in mind. And why would I involve this? You understand it's going to just stay in the way, be in the way, get in the way. So that's why I took it outside. Because when I differentiate, this is one of the properties of derivatives. When I differentiate a constant times a function, it's a constant times the function prime, right? Is this okay? So now I have 1/2. Now I can put it together. It doesn't matter anymore. It can be back. Let me do that. It doesn't matter. It can wait still, but we can incorporate it now. So the denominator is 2 plus x. Now the least common denominator is 2, the square root of 2 plus x. And this one is 2, the square root of 2 plus x. So this will be 6 this time, times 2 plus x, and minus 3x and minus 4. After all this effort, it better have something. It may not. So when I flip this, the denominator becomes 4, 2 plus x, the square root of 2 plus x. And the numerator is 12 plus 6x minus 3x minus 4. So finally I have 3x and plus 8. Beautiful. It's not even in the domain. Because this is negative 8 over 3, which is to the left of negative 2. So no inflection points, Because when I set this equal to 0, I get x equals -8/3. But -8/3 is here. It's not in the domain. So now I have to establish the sign. What kind of number is this always? Yeah, because we had to state that 2 plus x is greater than or equal to 0. So this is always positive. Now this crosses at -8/3. Positive slope, negative before a -8/3, and positive afterwards. So no worries at all. The function holds water, we say. But it was difficult to work with that. Yes? Say it again. So you want to check with plugging in?
Never mind. Sorry.
No. Maybe you see some.
I was saying x equals 0 is not that function. 0.
That's okay. But maybe you see something that I don't. So now we're ready to graph this function. So that's all I need, just this. Okay, -2, 0. -4/3, -1.1. 0, 0. It always opens up, decreasing. This is a local min. It also happens to be a global min. So it comes from this point, opening upward, decreasing, and continues to increase all the way, opening up. So this is a graph of f of x, x to the square root of 2 plus x. Questions? This is okay. Other types of problems that you are thinking of?
Will we have to do any of the old difference?
Yes. Yes, we will. I will ask you to determine a derivative using the definition of the derivative, which is the limit of the difference quotient. Yes. So let's choose one. Anything you want. It can be rational. It can be quadratic. It can be radical. That's pretty much it. Rational? Okay, very good. So let's use, and you can always check now. You know how, right? So let's choose a rational function.
About dx over sine x.
It's a combo. It's not a rational function. We can give it a shot. I don't know where we're going with it, but
Maybe at 9 o'clock.
Do x plus 4 over
X minus 4.
perfect. So f prime of x is limit as h approaches 0 from f of x plus h minus f of x divided by h. Very important, the definition of the derivative is the limit of the difference quotient. Very important to remember this. Good. So now you also have L'Hopital's rule. So you can apply it now. You can apply anything you want at this point on any problem. Okay? So then this is x plus h plus 4 over x plus h minus 4 minus x plus 4 over x minus 4 divided by h. Of course, I need an x minus 4. Now, of course, I need an x plus h plus, not plus, but minus 4. Even if you say, well, it's 0 over 0, why don't we differentiate? You don't want to differentiate in this stage. That will be very difficult. So limit sage approaches 0. The least common denominator must be the product of those two. And let's see what we get. This is x minus 4. So this is x squared plus xh plus 4x minus 4x minus 4h minus 16. And you know I'm going to run out of space. So minus x squared minus xh plus 4x and minus 4x minus 4h plus 16.
So in a problem like this on the test, we got to that second one, you'd be okay if we went right into low calculus.
Yes, but you still have to simplify it first. Yes, and you really don't want to multiply the denominator. Yeah.
But if it was a less.
Yes, absolutely. Yeah, you can apply anything that we studied right now, unless the problem says you must apply this, but it's not going to be that. Be creative. So remember, with the difference, with the limit of the difference quotient, what has to happen? All terms without h from the top must go away. Okay, and then h, eventually h in the denominator must go away. So then, these two out, and potentially other terms too, but definitely the terms without h must go away. So 4x with negative 4x, negative 4x with positive 4x, positive 16 with negative 16, and negative xh with positive xh. So as you see, I only have this and this left. So this is limit as h approaches 0 from negative 8h divided by, this is over 1, so I flip it, h, x minus 4, x plus h minus 4. And as expected, and now the denominator, when h approaches 0, the denominator goes to x minus 4 squared. So now on the side, scratch paper or not, it doesn't bother me. Just to make sure that I didn't make an error, I will differentiate. And I get the top prime, x minus 4, minus the top times the denominator prime, divided by x minus 4 squared, negative 8 over x minus 4 squared, as expected.
How much work that used to be.
We always get it wrong.
Yes, the algebra is so important, as you see. Good. Next question. Anything else that you can think of?
Oh, yes. One of those, find the tangent and normal line.
Oh, yes.
Okay. A tangent and a normal line. And that was at the end of chapter 3, I believe. Yes. Okay. So I see two problems here. I don't remember which one. I think we did one of those. On page 265, 60 or 61, I don't remember which one. So find equations of the tangent line and normal line to the curve at the given point. 60 or 61.
60.
Okay. Don't remember which one we did. I'm sure we did one of them, but I don't remember which one. So 60 on page 265. And this is x squared plus 4xy plus y squared equals 13, and the point is 2, 1. So here's this curve. At this point, 2, 1, there is a tangent and there is a normal line. And we want to determine both equations. What do I have to determine? Because the tangent will be y minus y1 equals the slope times x minus x1, in which x is 2, x1 is 2, and y1 is 1. But the question is, how do I find the slope? Because once I have that slope, then I also have the slope of the normal line. How do I know then if I determine that this slope is 5, what will be the slope of the normal line? Negative 1 over 5. The product has to be negative 1. Right? So if this happens to be 5, then this will be negative 1/5. So that the product is negative 1 for two perpendicular lines. But the question is, how do I determine the slope? Exactly, dy over dx. So I differentiate the left-hand side and I differentiate the right-hand side. So this is 2x plus, now careful, this is a product. First function prime is 4x prime is 4y plus 4x times dy over dx and plus twice y dy over dx. Are you surprised that I ran out of room? No. Okay, so from here we will determine an expression for dy over dx. I will move these two to the other side, and at the same time I would like to divide everything by 2. So this will be 2x and plus y dy over dx equals negative x plus 2y.
Sorry, I don't know if we're too far on this. You went off the paper.
Exactly.
Okay.
I always do. So this is 1x, this is 2y, but once I move them to the other side, they become negative. This will become 2, and this will become 1. And therefore, dy over dx equals negative x plus 2y over 2x plus y. Okay, so after all this effort, I have an expression for the derivative of y. But what do I do now? Plug in. What do I plug in? X equals 2 and y equals 1. Indeed. And let's see what we get. So this is 2 plus 2, the top is 4. And this is 4 plus 1, and the bottom is 5. If this is negative 4/5, so this is negative 4/5, look like that. I just didn't even, okay. So, okay, so negative 4/5, then the other one will be 5/4. I just picked 5 out of the blue.
Sorry.
Go ahead. Yes, so once I find the slope of the tangent line, at that point, I will determine the slope of the normal line. And now I will get two equations. One equation with a slope of negative 4/5, like y minus 1 equals negative 4/5 x minus 2. And the other one will be y minus 1 equals 5/4 times x minus 2. So this will be, bless you, the tangent, and this will be the normal. And yes, I should solve for y. I will distribute and move 1 and move 1 on to the other side. Very good question. Anything else that you would like to go back to?
We could do one more when we have two. I forgot what it's called, where you're differentiating with the
Implicit?
implicit, yes.
Very good. Yeah, this was implicit. So this example was an implicit differentiation.
We just do one more.
Yes. Yes, of course. So implicit differentiation, this, I'm looking at the end of chapter 3. Okay. Of course, there is no example, so I have to go back to 3.3.5. Okay, here's an example. And you tell me if this is what you had in mind. Let's say y sine 2x equals x cosine 2y. And we're asked to find dy over dx. Is this a good example?
This is implicit.
Yes, because we cannot solve for y. Is this okay? Perfect. So we differentiate the left-hand side, and we differentiate the right-hand side. When we differentiate the left-hand side, remember this is a product, right? So y prime, we don't have it, so it's dy over dx, multiplied by sine 2x plus y, multiplied by sine 2x prime. What do I write? Exactly. Yes, you do. Thank you. So that equals another product now. First function prime, so cosine 2y plus x multiplied by cosine 2y prime. So first I differentiate cosine, and I get, very good, 2y times the inner function prime, 2 times dy over dx. Very good. I managed to stay within one page this time. Okay, now obviously this term will go to the other side, and this term will go to the other side. So, and I will factor out dy over dx sine 2x plus 2x sine 2y. It was a negative term. When I moved it to the other side, became positive. Now this is a positive term, but I have to bring this one to the other side, 2y cosine 2x. Is this okay? Any questions on this? So now this is this over this. So dy over dx cosine 2y minus 2y cosine 2x over sine 2x plus 2x sine 2y. So what I highly recommend also is make a list of these topics, and every now and then, till you finish with calculus, calc 2, calc 3, whatever you need to do, just put them aside. Like, for example, implicit differentiation, what it means, the chain rule, what it means, how to find a definite integral, what happens when I differentiate a function in the form of an integral. Just the major topics. Just go through the checklist if you don't want to flip the pages in the book. And make, so you have this handy, and if you need anything, moving forward, you have just a list of topics in your little notebook. Because it will be very easy moving forward. If you need to review something, oh, okay, that is. Or differentiating 1 over x, which is negative 1 over x squared, or integrating something. So I would recommend that. Not when you review, because you're going to review everything. Just make some notes. Or go, as I said, through the checklist. It's a good idea to, every now and then. And after, when you start Cal 2 in the spring, do that again. Or have it handy, because, we forget things. We really do. Okay, next question. What I also would put on that list is that the integral of 1 over x dx is natural log of the absolute value of x plus a constant c. So I would put that too. The substitution rule, also, an example or two. Sure, yes, that's chapter 5. Let's go back. I will list the 7 indeterminate cases on that in the notebook. I will put an example with L'Hopital's rule in there as well. Because it will be much easier for you to go back to reference it and start going through all 5 pages, 5 chapters in the book. Okay. On page 417. I don't know if we did 35. Let me know, and we can choose another. On 417. The integral from secant theta, tangent theta, it's the product, over 1 plus secant theta over times d theta. Okay. And to that notebook later on, you will add a lot of things like integration by parts. You're going to add techniques of integration with trigonometric substitutions. You're going to add partial fraction decomposition. You're going to add areas and volumes. And you're going to add series. And all the tests for series, if they converge or not. So once you have that notebook, you will grow. Okay. So looking at this, I know exactly what I don't like. What you don't like? Say it again. Right. I don't like a denominator with 2 terms because I cannot separate the fraction if I need to. And it's difficult to work with 2 terms in a denominator or more. Yes, I don't like that. And let's see if we are on the right track. So let u be 1 plus secant theta. So du, if du is easy in the problem, then we are on the right track. A number I can make up anytime, a factor, but not a function, always. So what is secant prime? D theta. So I'm in business then, because this is du. And then this is now, I don't want you to think that this is the scientific way of thinking. What I don't like, maybe that I can get rid of it. So, but this is the idea basically. It's not the scientific way, mathematical way, but it tells you what you would like to really denote by u. So this is the integral from du over u, which we know what it is. The absolute value of u plus a constant c. I had to add that constant on several of your tests. So please, when it's an indefinite integral, please add up the constant. Okay, and now I have no choice. I have to go back to my substitution. This is natural log of 1 plus secant theta plus a constant c. So what happens if you omit the absolute value? You're only looking at this side. You're not looking at the other side. So you are excluding half of the family of functions. Okay. Anything else? Are we okay with fundamental theorem of calculus part 1, in which for that continuous function we are able to differentiate both sides and find the derivative? Yes? Okay. Anything else? Optimization. Optimization. 54 caught my eye. I don't know if we looked at it or not. At which points on the curve so 54 on 334. If we looked at it, please let me know. At which points on the curve y equals 1 plus 40x cubed minus 3x to the fifth. I don't remember looking at this. Does the tangent line have the largest slope? At which points on this curve does the tangent line have the largest slope? So we're given a function and we're asked to find the tangent with the largest slope. How do I determine the tangent, the slope of the tangent? The derivative, okay. So then I get 120x squared minus 15x to the fourth. But now I want the largest of this. Exactly. I find the second derivative, which is 240x minus, is it 60x to the third? So I want to set this equal to 0. Find the critical numbers of this function and find where it is maximum. But I'm studying the derivative, to find where this one is maximum. Is that clear what we're doing? Okay, so then I have 240x minus 60x cubed equals 0. I will definitely divide by negative 60. I want it out of there. So then I have x cubed minus 4x equals 0. And yes, I will factor out x, and I get x squared minus 4. And I have three solutions as x equals 0, 2, or negative 2. But who knows what is what? So I can conclude before I study the sign of the second derivative. So this is double. So negative 2, 0, and 2. Okay, I have to go back to the original function, not to all this equation that I worked with. So this is negative 60x squared, and this is x squared minus 4. I would not even bother to study this. Why I would not bother to study 60x squared for the sign? Because it's always positive. So now let's plug in negative 5 here. Negative 5 squared will be 25, minus 4 is positive, with negative in front will be negative.
Shouldn't it be negative 60x times x squared minus 4?
Yes. Thank you. Thank you. Thank you.
Wait, why is it negative 60?
Because this is x and this is x cubed, and I can only factor out x, and I cannot factor out x squared. It was wishful thinking.
It was.
My error. No, it wasn't. It was an error. Sorry about that. My apologies. I can only factor out x. I jumped. So then I will have to make sure that the sign is correct. So again, this is incorrect now. So negative 5. So this is positive with negative 5, but negative 5 times negative 1 will be positive. Okay, now I plug in negative 1. With negative 1, this becomes negative. Negative, negative. So all three negatives. With positive 1, it's not going to make any difference. Because this is...
But yeah,
So, yes, it's negative and negative. Good. And then with 10, obviously it's negative. Okay, No, we cannot assume that. We cannot assume that. I can give you examples in which, so for example, here's an example. I'm coming back here and finishing up, but I want to answer this question. So for example, y equals x cubed, right? So y prime equals 3x squared. So when I have 3x squared equals 0, I get two options, well, but they are the same, right? So then it doesn't mean that it's going to change sign. So y prime is 0 at 0, but look at it. It's x cubed. X cubed looks like this. It doesn't have a max or min. And when you find the derivative, you get 3x squared. Although the critical number is 0, it will never change sign. So it's not going to be a positive, it's not going to be a max or min.
It doesn't matter that we're looking at second derivative.
It doesn't matter. It doesn't matter. In this case, we are looking at the second derivative for other purposes.
Okay.
But it doesn't matter. So do not assume that if you find a critical number for studying the derivative, or you find a value for which y double prime is 0, you cannot assume that the double prime will change sign, or that the derivative will change sign when it's 0. You can't. You have to study the sign.
So what
Yes.
does it look like if the second derivative, it doesn't change sign,
It's always opening upward.
even if there's a 0?
Yes, it's possible. Yes. Or it's only opening downward, and even if it's, yes. Yeah. If it doesn't change sign, even if it's undefined or 0 there, where undefined when the function is defined or is 0, it does not mean that it's an inflection point. Yes. So it can, for example, that function, the function can have a vertical asymptote at that point. So it cannot have, although it changes sign. Even if it changes sign, you cannot assume that it's a inflection point, unless the derivative, the second derivative is 0. Yeah. So coming back here, so obviously this is a typical for a max, and this is a typical for a max. This is not a typical for a max. So at x equals -2 and x equals 2, we will say that this function, at which points, so we only determine x, on the curve, does the tangent line have the largest slope? It happens that you will have the same slope. So when x is -2, y is whatever. When x equals 2, y is. So
Is it all the max or is the second derivative?
we're talking about the max of the slope.
Okay.
That's why we're discussing the second derivative. Yes. So -2. So it's 1 minus 40 times 8 and plus 3 times 32. And this one is 1 plus 40 times 8 minus 3 times 32. So if you give me these numbers, I'll give you the points. So what is it? 1 minus 320 plus 3 times 32. I got negative 223, is that correct? And the other one is 1 plus 320 and minus 3 times 32. I got 225. So the ordered pairs at which the function y equals has the largest slopes are -2 comma -223 and 2 comma 225. And this is a maximization problem.